Okay, so like I said, quiet please. Ashley, this way. Okay, Kara, this way. Right, I mean, this class is supposed to be some part trigonometry, and it's never much. But this year, because of the way the SOLs got pushed late, you know, it's not much either. But what we can do, when you get to pre-calculus, you don't do trigonometry until the second semester. And the first couple lessons are about building what we would call the unit circle. And we're going to do that today, build the unit circle, or at least part of it. And you'll see where it comes from, because you refer to it over and over and over again. It's the kind of thing, kind of like your multiplication tables or something like that, you need to have memorized. You know, if not all the information exactly, you need to be able to like refer to it, either by writing it down or by, you know, in your head, picturing where you're going, things like that. Now, trigonometry itself, the word means the measure. I copied this from the wrong place. This is actually wrong. It should have said, why is that not going? It should have said the measure of triangles, right? Because of the metry, not the study of triangles. And by the measure of triangles, what we mean is, you know, a triangle's got 3 sides, 3 angles, and it's the relationships between all of those things. You've done some of this already. In geometry, you studied right triangle trigonometry. And, you know, that was this. That was the thing where you might have memorized something like SOHCAHTOA, right? It was a way to help you remember the sine, cosine, and tangent, which are defined right here, right? So in a right triangle, if one angle is annotated as the reference angle, and usually, not always, but usually the variable they use to mark an angle like that is the Greek letter theta, right? So this symbol right there is theta. And that is by far the most common, but you can see other variables used as the angle. So if you're in the right triangle, if that's theta, the angle that we're interested in, then you can label the 3 sides. Now, the hypotenuse of a right triangle is always the hypotenuse of the right triangle. That doesn't change. But what side you consider to be the opposite side and which side is adjacent depends on the angle. Right? If my theta was up here, then the opposite side would be this. But because my theta is here, the opposite side is that. Right? So you have to, in your mind, you think, here's my reference angle. With respect to that angle, the 3 sides are opposite, adjacent, because it's next to it, hypotenuse. And then we defined SOHCAHTOA, you know, sine is opposite over hypotenuse, right? Sine theta equals opposite divided by hypotenuse. It's a ratio of sides. You divide, right? Cosine is adjacent divided by hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent. Tangent of theta, opposite divided by adjacent. So you got to set up a right triangle. You got to remember how we define those 3 angles. That much of it you have definitely done before, right? That is part of geometry. What you probably have not done, or you might not have, but there's actually 6 trig functions, right? These 3, sine, cosine, and tangent, you for sure already did, but there's 3 more. They're the reciprocal functions. Reciprocal means the inverse, right? You flip them. So the reciprocal of sine is the cosecant. CSC stands for cosecant. And again, since the sine is opposite over hypotenuse, the cosecant is hypotenuse over opposite. You flip it, right? The reciprocal of cosine is the secant, right? So since secant is adjacent over hypotenuse, the secant is hypotenuse over adjacent. And the tan of theta is opposite over adjacent. Cotangent, COT, is adjacent over opposite. Yes? We're not dealing with that now, okay? Well, just to I'll show you this. So on your calculator, you have sine, cosine, and tangent, right? Now, if you want to do, there is not a cosecant and a secant and a cotangent. It's not sine to the -1, cosine to the -1, tan to the -1. That is not what those things mean. Those are inverse functions, right? We did inverse functions, f to the -1, right? That's what that is. That's not the same thing as the multiplicative inverse or reciprocal. So you definitely wouldn't want to use that. Now, the truth is that this button over here that says x to the -1, that is one. You could say, you know, sine of something and then hit the x to the -1 button and turn it into the cosecant, right? Now, how you remember which one goes with which, right? The tangent, cotangent seem kind of obvious that they would relate to each other. But whether or not the cosine, the reciprocal of cosine is the secant or should it be the cosecant, that you got to keep straight somehow. The way I keep it straight is that you would have thought that the co goes with the co, but it doesn't, right? It's the sine goes with the cosecant, the cosine goes with the secant. So you have to have that part memorized. So that's probably new stuff to you. And we're not going to do much more than just introduce, okay, if you didn't know it, we actually have 6 trig functions, not 5, not 3. Okay, the other part to keep in mind here is the sine, cosine, all these functions here, it's not like sine times theta, right? This is like saying f of x, right? That's function notation. That's sine of theta is like f of x, right? The argument of the sine function is this thing here. And in every case, what kind of quantity is that? It's an angle, right? You always put angles inside of the trig functions, never anything else, right? Now, the value of the sine or cosine or any of these equals the ratio of sides, the particular ratio of sides that's listed right here. But you don't want to take the ratio of sides and try to put it inside the trig function. That wouldn't be right. The only thing that goes inside is the angle. So that happens all the time, that we try to take that, and I've got an example on the next slide. You know, here's a right triangle, Pythagorean triple, right? 3 squared plus 4 squared equals 5 squared. If I wanted to find the sine of theta, right, the sine of theta would be opposite over hypotenuse. Okay, in this triangle, the opposite is what? 4. The hypotenuse is 5. So it's 4/5, right? The sine of theta equals 4/5. You don't know what theta is, right? You don't have a value of theta. But don't try to go, oh, I'm going to go to my calculator now and say sine of 4 divided by 5, right? That absolutely is not correct. Never take the ratio and stuff it inside of the trig function. Okay. What would be the cosine? Adjacent over hypotenuse. In this case, that is 3/5. And the tangent is opposite. Don't do that. Over adjacent, which is opposite adjacent, 4/3. Okay, so don't try to make those the argument of the function. The argument of the function is the angle. We don't actually know what the angle is. We could figure it out, but we're not going to right now. Okay. So since angles are the important thing, mostly what we're doing here is just trying to learn about how we refer to the angles when we're doing these trig functions. And angles, you've dealt with, again, another geometry concept. An angle has a vertex and it has 2 sides, right? It has an initial side and it has a terminal side. The measure of the angle is how much does it open up, right? A small angle doesn't open up much. A big angle opens up a lot. But when we use it for trigonometry, it's actually, there is a standard position for the angle. The initial side is always the positive x-axis. Okay, always. And then the terminal side will be somewhere out here. In this case, they've drawn a terminal side in quadrant 2, and you can see that their arrow showing the opening of the angle, it's actually counterclockwise, right? The clock goes like this, so the counterclockwise is like that. That is defined as a positive angle, right? So this is counterclockwise right, equals a positive angle. You can have negative angles, but you just have to, that a negative angle would go clockwise. A positive angle goes counterclockwise. Okay, so that's, just trying to get our basics down. The vertex at the origin. Initial side, positive x-axis. It will open up in a positive direction by going counterclockwise around. So let's say I'm in the coordinate plane. I don't have to draw every time the angle, right? If my initial side is here and my terminal side was here, right, what would be the value in degrees of that angle? 90 degrees, right? And what would be the angle if I was opening up from here to here? 180, right? Because all the way around the circle once it's 360. So halfway around is 180. Halfway between 0 and 180 is 90. And actually that's a 90-degree angle. So what would be halfway between 180 and 360? 270. Right? Those are positive angles. We're not going to get into the part that says, in fact, you could call this negative 90. Right? It's going in the clockwise direction, so it's negative, and it's 90 degrees in that direction, which means that there's two ways to refer to this angle, negative 90 or positive 270. But we're not really interested in that right now. There's actually another way we could refer to this angle, 0. What if the terminal and the initial side were the same thing? It didn't open up at all. Then this becomes a 0. And we do have to take that into account now. So we are going from 0 to 360 degrees, right? That's how we label this. Okay, we did that. Okay, now the unit circle is a circle which got the center at the origin, has a radius of 1. The unit stands for the radius equals 1. Pass? Okay, so I can still label all these things, right? This is, I want to write this in the correct spot. Right? We've already said this could be called 0 degrees, and this can be 90 degrees. This will be our 180 degrees, 270 degrees. And actually, if we come back around, all the way around the circle once, we're back to 360. Now, what we're interested in, not just the angles now, we want to know what are the coordinates where the circle, at that angle, where the circle, for example, what are the coordinates of this point right here? Okay, since the radius is 1, right, r equals 1, this point has the coordinates of 1, 0. Right, what would be the coordinates of this point? 0, 1. Okay, what are the coordinates of this point? Okay, easy stuff. And then this one is 0, negative 1. Okay. So what we need to do, we're going to develop this unit circle. And the unit circle is going to have angles going all the way around. It's going to have coordinates for each one of those angles. And then we'll learn at the very end how those relate to the trig functions. They give us the values of the trig functions. So the first thing, we've got the every 90 degrees, right, just like we want it. Now we want to add the halfway in between 0 and 90 will be 45. And halfway between 90 and 180 will be 135. And halfway between 180 and 270 will be 225. And halfway in between 270 and 360, 315. All right. And now also notice that as we make these coordinates, that we would expect in this in quadrant 1, right, positive is X and Y. Negative or neither. But what about in this quadrant? Which is positive and which is negative? The Y is positive because it's above the middle, and the X is negative because it's to the left, right? And how about in quadrant 3? Right? Right, they are both negative, right? You're to the left and you're below, so they're both negative. And then what about this one? Positive and negative. So the X is positive because you're to the right of the middle. So the Y is negative because you're below the middle, vertically. Okay, so we are going to be filling in this unit circle with this information. In our last class, the quiz will be, you're going to get a blank and have to fill it in from memory, or from whichever way you can figure it out. Well, we've got more to add. I'm giving you a starting point and giving you this hard copy so you can start to fill it in before I add more to it. So you want to just fill in what you can already. There is one thing that is we're skipping over today that we'll add Thursday. So if you notice on your unit circle, you can see where the degrees go, right? You see the degree symbol? There is a blank in between that and the circle itself, right? That is going to stay blank today. We'll fill it in next class. But everything else on here we will have filled in today. So you should fill in, right, the angles that go here for degrees and the coordinates. The angle 90 and the coordinates. The angle 180 and the coordinates. The angle 270 and the coordinates. And then what is positive and what is negative in each quadrant. What's that? What's that? Copy. I mean, if you remember in geometry, that chapter that you did right triangle trigonometry, before that you did some other stuff, which we're about to use now. It all comes from that. Okay. So next, we're going to fill in halfway in the middle of each quadrant, right? You can see there's 3 lines in the middle of each one. We're going for the one in the middle. That's exactly halfway in between. We done copying? Okay. In order to come up with what we're really interested in here are the coordinates at that point. In order to do that, we're going to use something else that you studied in that same chapter of geometry, which is called the special right triangles. In this case, it's going to be 45, 45, 90 triangle. Do you remember doing that? Right, so why do we call it 45, 45, 90? Because the angles are 45 and 45 degrees, and it's a right triangle, so there's a 90. And when a triangle has two angles that are equal, that means that it has two sides that are equal, right? So the formulas that we use for the sides in a 45, 45, 90 triangle, you may have used n as the variable, you might have used x. I've seen it different ways. But if we say that each one of these sides, the legs of the triangle are n, then the hypotenuse is n times the square root of 2. Right? N times the square root of 2. Now, we know what the length of this side is in a right triangle. What is the length of this side? Right? If I draw a triangle right here, what is this side? What part of the circle is this? It's the radius. But what's the length of the radius? It's 1. We actually know if we're going to use a 45, 45, 90 triangle to come up with these here, we know that this one equals 1. I mean, that's all you need when you do these special right triangles. You got to know the length of one side, and then you can use the formulas to find the others. So if the hypotenuse n root 2 equals 1, then we can solve for the n, right? Divide both sides by the square root of 2. Rationalize the denominator by multiplying by square root of 2 over square root of 2. So n, the length of these two sides, is the square root of 2 over 2. It's equal, right? So this is the square root of 2 over 2. This is the square root of 2 over 2. Now, when I take this special right triangle, 45, 45, 90, and I place it on the unit circle, this becomes the x-coordinate. That becomes the y-coordinate. Right, so at this point right here, at 45 degrees, you can fill that in now. 45 degrees, root 2 over 2, root 2 over 2. Okay, now, once you know those dimensions, right, the fact is that I could draw the triangle over here, right? The triangle's still the same size because the radius is 1. What's the only thing that changes in the second quadrant? The x-coordinate would be negative because you're to the left of the middle. But the y-coordinate is the same because you're the same distance above the middle. It's still positive. So remember, that's why you got the positive, negative written there. All the x-coordinates in quadrant 2 have to be negative. The y-coordinate's still positive. In quadrant 3, they're both negative. In quadrant 4, x is positive, y is negative. So now we've done every 90 degrees. We've done every 45 degrees, right, in between. And then the last thing you add is every 30 degrees, right? So we need to add 30 and 60 and 120 and 150, right? That's why you've got the 3 lines in each quadrant, right? We just filled in the middle line of the 3 in each quadrant. Now we're going to fill in the others. But we used a 45, 45, 90 triangle to do that. Next, we need to use 30, 60, 90 to figure out what are the coordinates at those other places. So remember the dimensions of a 30, 60, 90 triangle, right? These are just formulas. The hypotenuse is 2n. The side across from 30 is n. And the long leg of the right triangle is n times the square root of 3. Right? These are the formulas that you used when you did this in geometry. Now, there's one of these sides we know the length of already, which is that one, because its hypotenuse of this triangle will be the radius of the circle, so that's 1. But if the 2n equals 1, you can solve for the n. N is a half, right? Which means this side is 1/2, and that's the y-coordinate. And then if this side is n times the square root of 3, then n root 3 is 1/2 times the square root of 3. Okay? It's the 1/2 from here in front of the square root of 3. But that's not usually the way we write it. We usually write root 3 over 2. So this is root 3 over 2. So at 30 degrees, we're going to have an x-coordinate of root 3 over 2, a y-coordinate of 1/2. Which is bigger, square root of 3 over 2 or 1/2? The square root of 3 over 2 is bigger, right? This is n times the square root of 3, and square root of 3 is 1.7-ish, right? Something like that. So you're multiplying the square root of the n, the 1/2, times a number bigger than 1. So this is always bigger than this. It makes sense because this side is across from a 30. This side is across from a 60. So this has to be smaller than this side. Okay, so now I can use this to go to the unit circle and fill in. At 30 degrees, the x-coordinate is root 3 over 2. The y-coordinate is 1/2. Right? Yeah. At 60 degrees, right, what's going to change? Right? If I drew my triangle here, then I would have across from the 60 degrees would now be my x. That'll be the 1/2. I'm getting that a little mixed around, but. You know, if I drew the triangle 30, 60, 90 here, then the 60 degrees is right here. So again, across from the 60 degrees now is the root 3 over 2, and across from the 30 degrees, that's the 1/2. Essentially, when you go from 30 to 60 degrees, you just switch these coordinates. Right? It's going to switch these two. And once you've got the 30 and the 60, then you can spread them to the other quadrants just by taking into account the signs, right? Like this point here is straight across from this point, right? So it's got the same y-coordinate, root 3 over 2, but the x-coordinate, instead of being a positive 1/2, now it's a negative 1/2. It's to the left of the middle, right? This point is straight across from that point. Right, so again, it has the same y-coordinate, 1/2, 1/2, but now the x-coordinate is negative root 3 over 2. Okay, if I move down to the quadrant 3, now they're both negative. Right, so straight down from here, the x was already negative, but now this y, this was positive 1/2, now it's negative 1/2. So you should be able to make sense out of, you know, how we took these here and then spread them around the circle just by changing signs. So now we've done the axes every 90 degrees. We've done the 45-degree angles, which are halfway in between the 90s. And now we added in the 30 and 60 in each quadrant. And that's all there are. You should have filled in everything now in that circle, on the unit circle, so that it looks essentially like that. I've spread mine out here, which is not correct, but I just want to leave more space for the writing. Yours kind of has them packed in there, which is correct. Those are the right angles. But. So all this is what you should have written on there right now. Now, when you have to reproduce this kind of thing, understand how many different numbers are there in the coordinates of these circles? I mean, 0 and 1, 1/2, root 3 over 2, root 2 over 2, and then they all repeat. I mean, there's only 5 numbers you've got to remember. Is it 5? Let's say 1, 2, 3, 4, 5. 5 numbers is all you've got to remember, right? And they're in order. Yeah. Oh, that didn't get erased. I erased this like twice. I don't know why it keeps showing up. That's what we're going to add next class. Yeah, don't worry about the radian. That's called radian measure. We'll get to next time. But just notice, for example, like if I'm going to tell what the y coordinates are at these points in the first quadrant, right? The y coordinate here is 0, right? Because it's on the x-axis. And then the numbers should get bigger as I go up. So the next higher number is 1/2, and then root 2 over 2, and then root 3 over 2, and then 1. Okay, they're always in that order. I mean, I have to grade these things. So when I'm grading them, that's what I'm doing. I'm starting right here. I'm going 0, 1/2, root 2 over 2, root 3 over 2, 1. Then I jump over to the x-coordinate. 0, 1/2, root 2 over 2, root 3 over 2, 1. I mean, I'm not actually making special right triangles anymore. We use that to explain where it came from, but we don't need that anymore, right? How about in this quadrant? Okay, start with x equals 0 here, and now they're going to be negative, but they're going to, in an absolute value sense, they'll increase. 0, negative 1/2, negative root 2 over 2, negative root 3 over 2, negative 1. Okay. Now we'll start with the y's. 0, positive 1/2, because y is positive in that quadrant, positive root 2 over 2, positive root 3 over 2, positive 1. Okay, then I start here. 0, negative 1/2, negative root 3 over 2, 2 over 2, negative root 3 over 2, negative 1, 0, negative 1/2, negative root 2, etc. Just repeat, repeat, repeat. Boom. And then these angles you should be able to figure out, right? The 0, 90, 180, 270, 360, halfway in between, and then the multiples of 30. Right. I mean, again, keep in mind that you've only got these 5 numbers, and they appear in that order, right? If you turn them into decimals just to see, I mean, these are the decimal values. So they increase from 0 to 0.5 to 0.71 to 0.85 to 1. So this is the increasing in that order. Okay, now that we have our unit circle, we can talk about the values of these 6 trig functions. The value of the sine of the angle is y, right? So if I go back to my unit circle, I would say, because the sine is the y coordinate, I would say that the sine of 30 degrees is 1/2, right? The sine of 60 degrees is root 3 over 2. Okay? The sine of 315 degrees, negative root 2 over 2. Right? And so the sine is the y, the cosine is the x. So those, if you know your unit circle and the coordinates, that much of it you should be able to get just by looking at the circle. Now, the rest of them, there's just a little bit of work to do. Like tan theta is the y divided by the x. And then these 3, the reciprocal functions, are the flips of the first 3. Like we said, you got to remember, tangent obviously goes with cotangent. So y over x becomes x over y. Right? Then you got to remember, does cosecant go with cosine or does it go with sine? It goes with sine, right? So put the cosecant across from the sine and put the cosine across from the secant. And now just flip it. Y, 1 over y. X, 1 over x. So for all the unit circle angles, that's what you're supposed to use. It's never going to, the questions will be worded in a way where it will not work for you to say, well, I'm just going to put in my calculator. Okay, it will not work. If you turn it into, what's the difference between these 2 answers and these 2 answers? These 2 are exact. These 2 are not exact. You round it off to write that down. These are irrational numbers. They would never terminate. They would never repeat. If you give a decimal answer because you just threw it in the calculator, then you're going to be wrong, right? It'll say find the exact value of the cosine of 30 degrees, okay, root 3 over 2. Now, could you go to the calculator and do cosine of 30 degrees? Yeah, and it'll give you that answer. It won't give you that answer. So that's what we have to memorize these things. There's no math textbook that doesn't just use these same numbers over and over and over again. So if you recognize them, it makes it really easy. Now, most of the time, I don't memorize this stuff. I don't memorize this. I don't even like sit down at the beginning of the test and draw it all for myself. But when it says, okay, I need the cosine of 150 degrees, in my mind, I go, well, let's see. On the unit circle, 150 degrees is like 30 degrees short of 180, right? That's the one where the x-coordinate is bigger than the y-coordinate, but the x is negative. So that's negative root 3 over 2, positive 1/2. I mean, I draw these circles all the time to just get straight on what I'm supposed to have. You know, you don't want to memorize this like, in the end, once we have the radian measure, I think it's 66 pieces of information. Okay? You don't want to memorize just like 66 disconnected facts. I mean, that's just a recipe to not remember stuff when they actually all make sense together. So you just remember how they fit together, and you don't remember that much. You can put together what you need when you need it. Okay. So no real homework other than, you know, you're going to have to be able to piece together this unit circle. Like so far, we've done the angles in degrees and the coordinates at every 30 degrees and every 45 degrees. Right? In next class, we will add the radian measure, the thing that had pi in it, which is, if you go on your calculator, if you didn't get one, that's fine because you really don't need it for anything here. But if you look into the mode there on the third line down, right, there's your two ways to measure an angle, radians and degrees. And the default is radians. It's not degrees. Right? Radian measure is the way we usually measure the angles in math and science, not in degrees. There's times you use degrees. It's not wrong to use degrees, but understand radians is actually the primary way. So we have to do that next class. But other than that, that's it.